Okay, so we are starting our review. We're starting with Chapter 4, Worksheet number 11. We're going to go through this pretty quickly so we can make it to our second page. So on page 1, we are classifying by sides. If we are classifying by sides, Mario, what type of triangle is this?
Isosceles.
Isosceles? How did you know that?
Because two congruent sides.
Isosceles because there's two congruent sides. We see that here at the 11 and the 11. Jaheem, what's our second one?
Equilateral.
How did you know that?
Because they have all equal sides.
Yep, because we have all equal sides. And then number 3, Bree.
Scaling.
How did you know?
Because there are no equal sides.
Scaling, because there's no equal sides. Nice job, guys. Our next group is, what kind of triangle has the measures of 30, 60, 90? Yep.
Equal angle. Oh, shoot. I mean, a cube.
So, how do you know it's a cube?
Because they got all. Oh, right.
So, what is it?
All right.
It's a right triangle, and how did you know that?
Because it got 90 degrees.
It's right because we have an angle that's 90 degrees. If we have an angle that's 90 degrees, it has to be right. Our next one is 84, 55, and 41. It's going to be acute because they're all less than? Yeah, they're all less than? 90. On your guys' quiz, 1, the number one thing that I saw that people missed on the bonus was when we were talking about acute and obtuse. You guys referred to everything as above 180 or less than 180. But that interior of a triangle is 180 degrees, and a line has a measure of 180 degrees. But acute is less than 90 degrees, and obtuse is greater than 90 degrees. Okay, our last one says angle measures. Let's do sides. So it has side measures of, because that doesn't make sense. Side measures of 4 feet, 8 feet, 8 feet. So what type of triangle is this? Isosceles. Okay, and then our next one, number 7. We had a specific theorem that talked about this. So when we find the exterior angle of a triangle, what do we do with the two interior angles?
Subtract.
We add them. So the two non-adjacent interior angles, so that's that 102 and that 40, we add them. So x equals 102 plus 40. And we end up with what value?
142.
Yep, 142 degrees. So again, we take the exterior angle, and we set it equal to the two non-adjacent interior angles, and we add those.
But don't you have to add and then subtract by 1?
You can do it that way as well. So if you wanted to do it that way, you would take 102 plus 40, and then subtract that from 180, and that would have found the angle I'm going to write in red here. So that would have found this. And this angle is a linear pair with x. And then you take 180 minus the value you found there, and that would be your x value because they're linear pairs. So that is a second method. That's fine if you want to do it that way. And then on number 8, we're using what?
Same thing.
A little different. We're finding a missing side length. We're using, it starts with a P, ends with theorem.
Pythagorean Theorem.
Pythagorean Theorem. What does the Pythagorean Theorem say?
A squared plus B squared plus C squared.
Okay, and C is going to be our longest side.
16.
So that's going to be that 16 squared. The other two, it does not matter. So you can have x squared plus 6 squared. 6 squared is?
36 equals 256.
Is it 256?
It's 256.
We need to get our like terms together. So how do I do that?
Subtract 36.
We're going to subtract 36. We
220.
end up with 220 equals x squared. We need the inverse operation. So that's that square root. Is 220 a perfect square? No. So I'm going to bring this right up here. And I have the square root of 220. And I'm going to do my factor tree. So 2 goes into it how many times?
No. Can we use 20?
Yep. We can use 20. How many times does 20 go into it?
I'd say straight 10.
20 and 11.
Oh, yeah.
Okay. And then over here we have how many times does 20, what goes into it?
2 and 10.
2 and 10. And then what goes into 10?
2.
What has buddies?
2.
What doesn't have buddies?
5.
Yep, so we take the 2, it comes outside. What doesn't have buddies stays locked up. So 5 times 11 is 55. You all are smart. Okay, so on this one, we want to find the value of x. So we have three sides. What do we know about this triangle?
They all congruent.
They're all congruent. It's an equilateral triangle. So if all of them are congruent, what do we know? So they're all equal. You can choose any of the two sides and set them equal to each other. There, we can do it with any of those. So we have three options of doing it. One option's a little easier than the rest. It's your call. We can do any one that you'd like.
Wait, can we already?
Can we just straight ask?
So what did we set equal to?
4.
4x equals?
X equals 4.
4x equals 16 plus.
Divide by 4. X equals?
Oh, she won that one.
We did not have to do that. You could have done 3x plus 4 equals 16. You could have done 4x equals 3x plus 4. It's really your choice. But that was the easiest method in my mind. We have number 10. Number 10, we have two angles, 64 degrees, both of them. And we're looking for that angle x. So what value do we get for that? How do we set that problem up? Yeah, Deanne?
You add 64 together and subtract from 180.
That's 100% correct.
180 minus 138.
So that gives me 128.
28.
And then we take 180 because that's the sum of the interior of a triangle, and we subtract 128 from it. And what value do we get?
Wait,
52 degrees. Okay. Number 11 looks more complicated than it is, but it is a two-part problem. So we have to solve our bottom triangle. I'm going to highlight it here first. Yes.
So for number 9, what's that? 3x plus 4. We're gonna do nothing with that.
You could have, but you didn't have to. We are here, and we had to solve this bottom triangle first. So we're looking for the top angle in the bottom triangle. How do I go about finding this? 35 plus 23, and what do I do with that? And what value do we get there? 25, 3 plus 35. 58. And then what did you subtract that from? What value? 180. Because that's the interior angle of a triangle. Over here on the blue poster, you see it adds up to 180. We subtract the two angles that we know. So minus 58. And what value do I get? 122? So this angle here is going to be 122 degrees. Okay, now that we have that as 122 degrees, there is a relationship between this angle and the bottom angle on the top triangle. What's the relationship here?
122.
It's going to be 122. How do you know that?
Because it's at the bottom. I mean, that's what it is at the bottom. That's what they connect.
So we have two angles that are formed by intersecting lines that are not adjacent. They're congruent, but we know that because they are not adjacent. Because they're vertical angles, and vertical angles are congruent. So we know that this value has to be 122 as well. And then we're solving for this angle measure right here, this question mark. We know that the sum of the interior of a triangle adds up to be what value? 180. So we take 27 plus 122, which gives me 149. And we're going to take 180 and we're going to subtract that value. You've got it. So what value do I get with that? 31 degrees. Our next one.
I already got that.
So you want to walk us through the steps, Mario?
I just did 8x plus 2 equals 130. Then I need to do all this. I don't know if that's right.
So we know that the three angles, the sum of the interior angles of a triangle, add up to what value?
180.
So we're going to take 8x plus 2 plus 70 plus 60
I don't got it.
equals 180. Okay, we're going to combine our like terms. So 70 plus 60 is 130 plus 2 equals 180. We're going to subtract 132. 8x equals
40.
48. We're going to divide by 8. Give me 1 second, Reggie. 48 divided by 8 is? Okay. So, again, we are back here looking for this x. On this triangle, what do we call this side?
C squared.
It's going to be the c value.
Hypotenuse.
It's going to be our hypotenuse. The hypotenuse is the side that's opposite of that right angle. But you're right, we're using the Pythagorean Theorem, which is a squared plus b squared equals c squared.
O squared plus 3 squared. So 16 plus 9 equals c squared.
Okay.
That's x.
We're looking for x, so I just substituted in the value we had. So our symbol was x, so I just put it in. Okay, so 16 plus 9 is 25 equals square root both sides for the inverse operation. X equals
5.
Okay, so since all of these ended up being whole numbers, so no decimals with it, we see that this is actually a Pythagorean triple. Pythagorean triples are numbers that are whole numbers that satisfy the Pythagorean theorem. So a squared plus b squared equals c squared. Okay, so for number 14, we need to find the angle here that's the question mark. So our first step is to find this angle. How do we go about doing that?
35 squared equals.
We're not going to be squaring anything in this one. So 20 plus 35, which is?
55.
55. And what am I going to do with that value?
No, you're going to put it
180 minus 55. When we subtract it, what do I get?
122.
125?
Yeah,
So this angle right here is 125. Oop.
that's 5. So,
So
the other one, the same thing.
how did you know this angle here is also? Because they're vertical angles. Now we are interested in finding the question mark. We know a theorem that we've already used in this lesson and before that relates these two angles with that exterior angle. What is it? What is that theorem? What does it tell us? Not Pythagorean.
You gotta subtract.
So we know that the value of the exterior angle is equal to the sum of the two non-adjacent interior angles. So that means that, I'm going to switch my color. That means that 156, which is my exterior angle, equals 125 plus question mark. Okay, now we are going to subtract 125 to the other side to get our like terms together. 125, 125. When we subtract 125, what value do I get on my left-hand side? 31 degrees. We're back to the Pythagorean theorem for number 15. So we have a squared plus b squared equals c squared. My a squared, it does not matter if it's 40 or 30. So 40 squared plus 30 squared equals c squared, which is my x squared value. We're looking for x. 1,000 plus 900 equals x squared. Combine my like terms.
2,500.
Equals
X squared.
square root both sides.
Oh my god. Bro, you know what I'm saying. I might just have to-
X equals 50.
Where we see it.
Okay? Our last one on this page, it's really hard to see. So my last class decided what it looks like to them is a 13
You like
x plus 8. So we're going to set 13 equal to x plus 8. And we can do this because we have congruent angles. And the sides opposite of congruent angles are congruent. So that means x plus 8 equals 13. We're going to subtract that 8 to the other side. What value do we get for x? Oh, try again.
7.
Oh, 5. Breaking my heart there, kid. Okay.
Alright, so 5 plus 8.
Is?
12.
No. 13. Okay.
Well, I'm just trying to get it over with. You don't know what y'all tripping for.
Okay, so we're going to finish 17, 18, and 19. They both involve the distance formula. All three of them involve that distance formula. So that's the part of 4.3 that we did not quiz over already. Okay, so AB equals x2 minus. Okay, so that's our distance formula.
Okay.
Using this, we now just have to tell which ones of these coordinates are x1, y1.
Is x1, y1.
So we have x1, y1.
Yes.
Here we have.
Negative x2, y2.
Okay, now we're just going to substitute it into that formula.
Okay.
So AB equals the square root of -3 minus squared plus minus squared. -3 squared is 9 plus 4 squared is
16.
okay. 9 plus 16. Square root of 25 is okay. Our next one, we're using the same formula. Now we have x1, y1, x2, y2. Finishing this up the same way we did the last one, we're just going to substitute in. We have AB equals the square root of, what's my x2? Okay, so x2 is what value? Okay, so we now did -2 minus 8, and then we have -3 minus 4. So -2 minus 8. That's where you guys jump in. So we have -10 squared plus -3 minus 4. Ready? -7 squared. So we end up with the square root of 100 plus. Do we know anything that goes into 149?
Yeah.
So try it.
13.
It's 13. Try it. So we see that neither 7 nor 13 is going to work. Nothing else that we can come up with off the top of our head is going to work. So I'm okay if we just AB equals.
It's a perfect square.
16 does? Say 16 can't because that's even. Okay, so over here we have the last one of this type. X1, Y1, X2, Y2. We have AB. Again, we're just substituting it in. So we have x2, -3 minus 9 squared plus -6 minus 1 squared, which equals -3 minus 9.
6.
-12 because they're both negative.
Oh, you said -3 minus.
Please be nice to each. Okay. So we have -3 minus 9 squared plus -7 squared. Over here, we now have -12 squared is 144 plus 7 squared is. Add those two together. $193. Does anything go into 193 that we know? Not off the top of our head. I'm okay if you just circle that. So for this one, we're going to do what we did the other day, and we're classifying between right, obtuse, and acute. To classify it, we need to figure out which one's C. Which one's going to be the C value? It's going to be that 12. 20 is actually the problem number. So remember that 12 is the biggest side, and the biggest side is going to be C. So we have 12 squared Thank you, Randall. So we don't know the inequality sign or the equal sign if it's going to be in there yet. So we're going to have 144 box 100 plus 9. 144 box 109. So is 144 greater than, less than, or equal to 109?
Greater than.
So when c squared is greater than a squared plus b squared, what type of triangle it is? Therefore, it's obtuse. Okay.
15 squared equals
15 squared
plus 9 squared.
12 squared plus 9 squared. We have 15 squared, which is 225. Box 144.
Plus 81.
Okay, when we add that right-hand side, what do we get? 225. So is 225 greater than, less than, or equal to?
Equal to.
When it's equal, what do we know? It is a right triangle.
Why won't you just draw a triangle?
You could. And then our last one is what's
44 squared equals 42. 42 squared plus 18 squared. Box.
because we don't know what the sign is yet, so we put a box. So 44 squared is 1,936 equals our box, and then 1764 plus
300.
we add our right hand side 2088. Is that side bigger, smaller, or less, or equal to 1936?
It's bigger.
So we see that 1936 is less than 2088. So that type of triangle is this? So cute. Our last one on this page. So for the last one on this page is what we did yesterday. So we're using the fact that these are medians and they're intersecting at the centroid. And so we know that the side with the vertex is going to be the 2x, and the side without it is going to be the x. So we have Km, which is our median. Okay, so our first part is we're going to set up with Jahim sitting up. Sorry, Jahim. So Km equals KP PM. Okay, we know that the part with the vertex is going to be that 2x. So that KP starts at the vertex and meets at the centroid is going to be that 2x. The part without that is going to be x. So from the centroid to a line that's bisecting the side that it's bisecting. And so we have that the part with the vertex to the centroid is 2x. From the centroid to the side that it's bisecting is going to be x. So then we know the length of Km is 18. We substitute that in. We have 18 equals 3x. Divide by 3. X equals 6. But we're not done. That's just the part of it that we needed to find there. Now we're going to substitute it back in. Kp equals 2x, which equals 6, which equals 12. You're right. Okay, and Pm equals x, which is? Yes, thank you. The next one is Km again, so we can set it up the exact same way Jahim set it up in this one. So we have Km equals Kp plus Pm. We know here that the Km is 120. Kp is again the side or the part that is the segment that's starting from that vertex. So we know that it's going to be 2x. And the part from to the centroid to the other half is just going to be x. Yes, Jahim?
Where does the 2 come from? That's in front of this.
Oh, it comes from the fact that the Kp here equals 2x. So this distance is that 2x. And so that's a formula we had from yesterday. When we set this up, the median is divided from the vertex to the centroid in a segment that's 2x length. And from the centroid to the part that is bisecting the segment of the side, it's just going to be x. Okay, so we continue here. And we see that Km is 120. Kp is 2x plus x. We have 120 equals 3x. We divide by 3. X equals try it again. X equals 40. We take what we have there and we're going to substitute it back in. We see that KP equals 2x, which is 2 times 40, which is 80. K or PM, which is just x, which is 40. Our last one on this one is we now have KP. KP is the distance from my vertex to the centroid. So I'm going to put that in as 16. We also know that that's also going to be equal to that 2x. The part from the centroid to the side that it's bisecting is going to be x. So we have Km equals Kp plus Pm. We have Km, we don't know the distance of that, that's what we're looking for, equals Kp, which is 2x plus x. We know that Kp is what value?
16.
Yep, so we have 2x equals 16. Divide by 2. X equals 8. So now we just substitute that in to solve for Km. Km equals 2 times 8 plus 8. So we have 16 plus 8, which is 24. Nice job. Okay, so the side opposite of the right triangle is called, or the side opposite of a right angle in a right triangle is called what? It's called the hypotenuse.
Hypotenuse.
All the vocab will be on the test.
No. So now we spelled hypotenuse correctly. We're going back to this. The congruent sides of an isosceles triangle are called the Nikwa. This is all you legs. And the side that's not congruent to those two is called the base. Okay. The segment from the vertex of the angle to the midpoint of the opposite side is called the...
They're legs.
Yeah, that's legs. Ooh, not yet. What's the other one? It starts with an M?
Midpoint. Median.
The median. So that's our yesterday's lesson. And our median goes from our vertex of the triangle to the midpoint of the opposite side. The two sides of a right angle that form the right angle, the two sides of a right triangle that form the right angle are called what? Nikwa, they're called the
Legs.
legs.
Head, shoulder.
Okay, and then where they all intersect, so where all the medians intersect is that centroid.
Lip noise.
Okay, so we are going to find the measure of angle 1. How do we find the measure of angle 1? So we can do that method. You add up the two angles and you subtract them from 180. And then you can subtract it from 180 again with the angle you found because they're linear pairs. The other option is we know the exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent. So we have the measure of angle 1
115.
equals 52 plus 63 degrees. And Mario, what'd you get?
115.
115 degrees. Okay, for number 7, it's the same scenario. So the measure of angle 1 equals 54 degrees plus 83 degrees. What value do we get? 137. And then number 8, we are just finding the missing angle, so we're looking for the measure of angle 1. We know that the interior of a triangle adds up to 180 degrees, so we take 75 plus 35, and we get what value? 110. We subtract that from 180. 180 minus 110 is? It's just going to be 70. And then I'm going to scroll down, so give me 1 second. Okay, so now, once again, we are solving for the value of x in triangle number 9. We know something special about these two angles. What do we know about these two angles?
They need to be the same.
They're going to be the same, and we know this because the angles opposite of congruent sides are congruent. So we can set those two equal to each other. So I have 49 degrees equals 2x plus 5. Combine my like terms. I'm going to subtract over 5. I get 44 equals 2x. Divide by 2. X equals 22. If I wanted to find the measure of angle B, I would take that 22, substitute it back in, and then add 5. So 2 times 22, which is 44, plus 5, which will give me that 49. For number 10, we're back to the Pythagorean Theorem. So we're looking for x. So which side is going to be my C? It's going to be 22. So we have 22 squared equals x squared plus 10 squared. What is 22 squared?
I got it. 484.
484 equals x squared plus 100. Subtract 100.
384 equals x.
384 equals x squared. We need to square root both sides. Is 384 a perfect square?
No.
No. So what do we have to do? So we're going to take our square root of 384 and we're going to do a factor tree. So what goes into 384? 6 and 64. Okay, 6 and 64. 6 breaks down to 2 and 3. 64 breaks down to 8 and 8. At this moment, you know that 64 is a perfect square. You can circle your 8. It goes out. What doesn't have a buddy is the 2 and the 3. We multiply those together and we get 8 square root of 6. So x equals 8 square root of 6. We are on number 11, and then number 11, this will be the last one we can do today. What do we know about this triangle?
It's equiangular.
Equiangular. Equiangular triangles are also?
Everything the same.
Yep, everything's the same, which means the sides opposite of the congruent sides are congruent. Yeah. So we have 4x equals 5x minus 4. Combine like terms. I'm going to subtract 4x. I'm going to add 4. I end up with 4 equals x. Okay, so we already did one like number 12. So once again, we're using the Pythagorean Theorem. So we need that a squared plus b squared equals c squared. We know the c is going to be our longest side, which is our hypotenuse. So now we have 40 squared plus 30 squared equals c squared, or x squared. Let's change it to x squared. Equals x squared. 40 squared is going to be 1,060. Let's try this again. 1,600. And then 30 squared is 900. We actually did a problem just like this earlier on the review. This is going to give us 2,500 equals x squared. I'm going to square root both sides. When I square root both sides, I get x equals the square root of 2,500, which should just be 50. Our next one, we have an exterior angle measure of 120, and we're interested in finding the measure of angle x. So our first step is we actually need to find this measure here. So we know that 120 and the angle that I just pointed to are linear pairs. So that means they're going to add up to 180. So I can do 180 minus 120 equals 60. So that means this angle measure here is 60 degrees. Based on that, we also know that this triangle tells us that the two sides are congruent, which means that these angles are congruent. So that means that this is also x. Now that we have that, we know that 180 equals 60 plus x plus x. You might see where this is going because you know something special about the 60. And we see 180 equals 60 plus 2x. We're going to combine like terms, so we're going to subtract 60. That gives me 120 equals 2x. Divide by 2, divide by 2. X equals 60 degrees, yes. Okay, our next one, again, we see that we have a triangle that has congruent angles, which means that the sides opposite of them are congruent. And so that means that 16 equals 3x minus 2. We're going to add 2, add 2. We get 18 equals 3x. We're going to divide by 3. X equals 6. Okay, again, we're now back to that distance formula. So we know the distance formula is AB equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So now we decide which one's x1 and y1. So I'm going to have this one x1, y1. I'm going to call this one x2, y2. Using this information, I'm going to find the distance AB equals the square root of x2, which is 6, minus 2, quantity squared, plus y2, which is negative 4, minus 5, quantity squared. Over here, I'm going to combine my like terms. So 6 minus 2 is 4. 4 squared is 16. And then I have negative 4 minus 5, which is negative 9. Negative 9 squared is 81. 16 plus 81 is going to be 97. So we see that square root of 97 and the square root of 97 is 97's prime, so you can just leave it as the square root of 97. I'm going to erase this portion, so let's erase that since I don't need it to extend that far. And then we're going to do the same process for our next one. I'm going to change colors so we can make sure we keep our problems separate. And then we see that we have x1, y1, x2, y2. We're going to fill out that same formula. So AB equals the square root of x2, which is 3, minus negative 8, quantity squared, plus, and then it's going to be 7 minus 7, quantity squared. So 3 minus negative 8, that changes both these into a plus sign. And so we get 3 plus 8, which is 11. So 11 squared is 121. 7 minus 7 is 0. So I have plus 0. The square root of 121 is going to be 11. So the distance is going to be 11. And then our last one, we see that we have A and B. Try not to draw through our problem. Okay, so here we have x1, y1, x2, y2. And again, we're going to use that same formula. So we have AB equals x2, 0 minus 5, quantity squared, plus 6 minus 4, quantity squared. We end up with square root of negative 5 squared is 25, plus 6 minus 2 is 2 squared, which is 4. So square root of 29. Okay, so I recorded it, solved it, and then I realized I wasn't actually recording. So what we did is we remember the part from the vertex to the centroid is going to be a distance of 2x. And then from the centroid to the part where it bisects the side opposite is going to be a value of x. We also wrote down our statement saying that CD, the whole segment, is equal to the sum of its parts, so CQ and QD. We know the length of CD is 12. And then we know that CQ is 2x and QD is x. So we end up with 12 equals 3x. We're going to divide by 3. X equals 4. Now that we have this value, we're going to substitute back in to solve for what we know. Well, we see that CQ equals 2x, and we know our x value is 4. So 2 times 4, which is 8. Over here we have QD, which equals x, and the x value is just 4. So we have our two solutions right here. It's going to be the same setup for the next one. We see that CD is the median, and it has a value of 18, and we want to find CQ and QD. So we're going to start with that statement of CD equals CQ plus QD. Then the portion that is from the vertex to the centroid is 2x. So I'm going to write in 2x. The part from the centroid to the side that's being bisected is just going to be x. I'm now going to rewrite this statement with the information I know, which is 18 equals 2x plus x. I get 18 equals 3x. I want to get x by itself, so I'm going to divide by 3, which means that x equals 6. Now that I have x equals 6, I want to find the values of CQ and QD. Well, we know that CQ equals 2x, and that's just going to be 2 times 6, which is going to be 12. And then we know QD is just the value of x, which is going to be 6. And then we're on to our last one of this type, where again we have the full length of the segment. So again, we're looking at CD. We have a total length of 6. So I can write my statement as CD equals the sum of its parts, CQ plus QD. Remember that we don't put the lines on top because we're talking about distance. The segment that is from the vertex to the centroid is 2x. The part from the centroid to the part that's bisecting the opposite side is going to be x. So then I have 6 equals 2x plus x. 6 equals 3x. Divide by 3. X equals 2. Now that we have this, we're going to use that information to solve for CQ, which is 2x, which is going to be 2 times 2, which is 4. And then we have QD, which is x, which is just going to be 2. So we have our 2 values there. Okay, so looking at this one, this is slightly different now because we have the value of FQ. We know that FQ is 4, and we want to find that total segment length and then the part from the vertex to the centroid. So I'm going to write out my original statement again. So TQ, my total segment, equals my TF plus FQ. We know the part from the vertex to the centroid is 2x, and we know the part from the centroid to the part that's bisecting the opposite side is x. So we see that 4 equals x based on this information. So we go down here and we see that TQ equals 2x plus x. TQ equals 2 times 4 plus 4. So 2 times 4 is 8 plus 4 is 12. So we found TQ, and then if we're looking for TF, TF equals 2x, which is 2 times 4, which is equal to 8. We have a similar situation in number 22. So for number 22, we have the distance of FQ is 7. So again, they're giving you that smaller portion. And we know that's also x because it's on the side that's bisecting the opposite side, and the part coming from the vertex to the centroid is 2x. So we're going to write that statement. TQ equals TF plus FQ. We see right here that 7 equals x. We know that TQ equals 2x plus x. TQ equals 2 times 7 plus 7. So 7 times 2 is 14. 14 plus 7 is 21. Then we want to find that TF. TF equals 2x, which is 2 times 7, which equals 14. Our last one of this type is we are now given FQ. So based on the fact that FQ is 2, again, this is the portion that is from the centroid to the side that's being bisected, is going to be a distance of x. The part from the vertex to the centroid is 2x. So we have TQ equals TF plus FQ. We see that TF is 2x plus FQ, which is x. We know that x equals 2 based on this portion right here. So 2 equals x. So I'm going to substitute that in, and I get 2 times 2 plus 2, which is going to give me 6. So TQ equals 6. And then TF equals 2 times 2, which is 4. So classifying these triangles by the angles, we look at the first one, and we see that all 3 of the angles are underneath 90 degrees, which means that they are acute. The second one, we see that there's a right angle mark, which tells us that this is going to be right. And then the last one, we see that we have an angle measure above 90 degrees, which means this is obtuse. Last but not least, we have identify the side opposite of the angle. Well, we're looking at angle A. Angle A, what's opposite of it, is segment BC. So remember, we put a line over it. We have angle B, and the side opposite is AC. And then we have angle C, and the side opposite of that is AB. Good luck on your quiz tomorrow.